thanks everybody for coming today, and thanks Matt for having me, and Pivotal for having us tonight. So tonight I'm going to talk about consumer-driven contracts in the context of microservices, and obviously in the context of continuous delivery. So if that works. Yes. Okay, so who am I to talk about all this? So I'm a technical team lead in a company called Newsweaver. So we're based in Ireland. We're in a software as a service company, so we deliver an internal comms platform. What are internal comms? It's essentially for very large companies that have communications to do across the globe. They want to improve their communications, kind of unify all their channels, and giving general tools for them to manage their content, measuring their engagement across the channels and all that. That's it for the background. I won't be talking about what we're doing anymore. But I've been working in this company for more than 8 years now, and first 6 years was essentially working on a very large J2E application, and that can be quantified as a monolith, if we want to talk about that, and I think we're going to be talking about that afterwards. It's still an app that's going great. It's making for 90% of the business, so I'm not going to be dissing some things on monoliths. But 2 years ago, I moved to a new team where we started a new product. It was greenfield enough that we said, okay, let's put a focus on what was really bugging us, which was continuous delivery that was not possible, long release cycles and all that. So we focused a lot on continuous delivery, and microservices emerged as our architecture of choice for this. And essentially now all our new work is around microservices and splitting the monolith in different microservices. So just a bit of background. If we're talking about microservices, usually nobody started from scratch. We all started from something like this, which is what I was mentioning as before as a monolith. And if you're lucky enough, there is going to be some components in there that you think are kind of separate. But if you're unlucky, maybe there's no colors there and it's just one big brick. And there's that big database under it. The other side, so if we're moving from this side to the other side, which is more, let's say, decoupled, the boundaries are clearer. It's more concise of saying each thing does one thing and all that. So the concepts are clearly more separate on the right-hand side. But one thing we don't see here is the interactions between all these things. When we're inside the left-hand side, the interactions between all these components, and maybe they're just classes or interfaces, they're a lot more implicit. We don't really think about them. They're verified at compilation time. You can think about it if we're talking in Java about an interface that has methods, that each of the methods have names. Your class, your beans have fields. And if you go and start changing the name of the fields, the compiler is going to start giving out to you. And it's not going to go very much further. So you have very quick feedback on refactoring and that stuff. When we're on the other side, their interactions are a lot more explicit. We have to really talk about them. We have to really decide, okay, now we have these two systems that we decide to develop separately. How are they going to communicate? It's a lot more central, and the compiler is not going to help you anymore now. So if we're talking about HTTP, so REST over HTTP, now if we're not adding more validation, and we didn't have any of it before because the compiler was doing it for us, well, it's going to be a lot easier to break if we're not careful. So what does this look like? If we take a very dumb example, let's say before all our authentication structure was in one big monolith. Now we decide, okay, the two teams are going to deal, one team is going to deal with creating the logins and the login apps and all that, but that team is going to need to access user information. It might be roles, it might be I don't know, some passwords and password verification, a lot of stuff that the login does. They only want to deal with the login pages. So each team manages one of the services, and the user service might have a bit of data in there, so we can imagine the list of users, that kind of stuff. So very simply, the login service might actually say, I want to look for a user called Pierre. So the user service will have expose an API. Might have documented, say, well, you can get users by sending a GET request to /user/the username. And it's going to reply with a payload, typically JSON, so that's kind of box standard REST API there saying, I'm going to respond to you with a 200 status code, and this is the body. So This is like, so that has a user, which should be the username, the name, and like a role that's just maybe publisher, editor, admin, or all that kind of stuff. If we go back in thinking in the monolith there, it could just be a simple call to a service class that might say, get me the user, and returns you a user class that has those 3 fields. So, but now we have that concept separate in 2 different things, and the rest call does the communication between the 2. The big question is, before, the compiler was checking all that stuff for us. Now, how do we test all this? How do we test that REST call, the REST endpoint is there? How do we check that the response code is what's going to be? And how do we check that the payload is going to be correct? So let's imagine now the login is working away fine. There's no problem. And the user's team is pretty busy. So, and requirement comes in. Actually, you know, a user doesn't have only one role now. It can have multiple ones. So they just go and start changing their API. And now a user can have multiple roles. So now the field is no longer role, it's roles. And it has an array of roles. So obviously, when we just look at that piece, saying, well, look, this is obviously something wrong that's happening. We're changing the payload. Unfortunately, that can be a lot more subtle than doing this. You can be changing a class that's going to be serialized to JSON with Jackson. So you're having a bad day, you don't really think about it. And if you're doing that with an IDE, you're going to be refactoring your class. And it's nice, but it's going to be refactoring your tests at the same time. And it's just going to look all good. Because now, well, you're testing your unit tests in the service, except, well, no, I know a user has multiple roles now. That's what I wanted. Let's look at it in terms of the kind of life cycle of that change now. So the user service is running in production with that implementation with a single role. Everything is fine. Monitoring is good. No error responses. And then we have the login service, which is happily running. Maybe there's not many people looking at it that much because it hasn't changed and it's pretty stable. And it's running away, no problem. Then the users team start implementing those changes. OK, let's refactor. Let's iterate over that, create pull requests, everything. Production, well, still everything green, no bother. Nobody has any problem. And obviously, on the other side, the login, everybody's still happy. Then we run our build. Our tests are passing. And our production is fine. So our tests are passing because we refactored it to integrate our new change. Well, obviously, nothing changes production. Login service is going well. So you could probably guess where I'm going at with this. And now we're deploying to production. So we're happy. Our build is passing. Now we have multiple roles per user. And the nice thing is now for the users team, everything is still going great because they have their monitoring. They don't really see any more error responses. They might see a little bit less requests, but we never know. Or actually, they will actually see the same amount of requests and still responding with 200 and all that. But whoops, people can't log in anymore. And then if you're lucky, there's monitoring that's going to tell you that. If you're unlucky, then the phone is ringing, and then it's like, OK, what happened? Then the login service team is going to go, well, why did you change this? It's not our fault. We didn't change anything. And then starts the blame game of who did the mistake. Well, the main thing is maybe we should have tested this before going into production. So that was a bit of a crazy example of moving from our build to production directly. But isn't that crazy, though? The only problem is, well, what should we really have tested? There it's a very obvious case of, well, we kind of want to test that people can log in. It's still pretty core to our system, but there might be a lot more than that. Maybe the real test here is the interaction that we've changed, did we break it? And who should be testing that? At what stage should that be tested? Ideally, testing is there to stop us from doing something stupid, and we want to know that as early as possible. But testing is also there to make sure that, well, when we do one test, it has to be for testing one thing. When the test breaks, we want to know straight away what's wrong, rather than having to investigate everything after. So let's go. Users team is told now by the logins team, look, when you make a change, you have to check that users can still log in because, well, we don't trust you anymore. So now the user seems to go, well, that's fine, okay, so give us your service, and whenever we make a change, we're going to start your service, and link them together. And well, unfortunately, the login service is kind of annoying to test because there's a lot of SAML, identity provider, redirections and stuff. So we say, well, look, if you want to test to log in, we're just going to start the front end for this so that we can just write a nice UI test that's going to fill in the blanks and log in into it. So that looks fine. Let's go in that. But then I forgot then we actually do kind of IP restrictions kind of stuff in our login. So we're going to need to start this guy as well. Or we need to actually add some data as well. So we'll stop a little bit of data in here. So, okay, let's go. Let's run this. Oh, crap. We need tokens now. So when we log in, we need to generate tokens. And, well, it's nice because we decoupled everything, but now we have another service that deals with the tokens. And that token needs certificates. So we need another service that's for certificates. And now we need to generate keys as well for this. And we're going to get certificate errors. And so this becoming a bit of a nightmare there. And well, we only wanted to test this bit. This is a bit sad now. There's so many things wrong about this approach there for that test. Well, first of all, it's the users team that's doing this. None of the stuff that the users team has started there is part of their concern. They shouldn't be concerned about any of these other things. Second thing is, well, we're going to start, like this is a simple example there. We're starting 3 or 4 or 5 services. The environment will start taking up time to just come up. We need a place to run all this. And let's say a dependency changes. The user service is going to start breaking its build because now the dependency has changed. And well, maybe one of the services has changed behavior. So it's like this is turning into a full end-to-end acceptance test. We're slowly dragging everything for testing our one interaction. I'm not saying end-to-end acceptance tests and that kind of stuff are not valuable. But this is not the place for this. We wanted to know really early, well, did we actually break something in our interactions? Anytime we can test something earlier, faster, and with more reliability, because end-to-end acceptance tests are slow to do, they're painful to maintain. So, and they kind of give you an illusion of coverage. There, we really have that piece that said, well, we want to verify that we're not breaking interactions. So this is where the contracts are kind of coming into play there. So we're back to our interaction between our 2 services, and what we want to verify really is that this arrow is not broken. So the idea is that we put that interaction now back at the center of the problem, and we're going to create a contract between the 2 services, making things more explicit. So we have our 2 teams, our authentication team and our users team, and now they're going to agree on a contract over that interaction. And that contract is essentially saying that now it's not an API specification, it's not a Swagger file or YAML file or just a markdown. It's just saying now, because these kind of things drift away. It's inevitable, we're never going to be updating it, and it's going to be a manual process to verify that we actually agree from both sides. And without the automation, then we're losing all the power on that. So that contract is going to be there so that the consumer side, so the consumer side would be the login service, consuming the API from the user service. The consumer will have to ensure that whatever they're sending in terms of requests is done the way the contract is specified. And the other side, the provider is going to make sure that, well, whatever I'm accepting and whatever I'm responding with, this is the way the contract is specified. So we generate the contract and then we're going to validate it. That's the broad concept of it. So now I'm going to talk more specifically about one approach to this, which is called Pact. A lot of people are like, so this is a framework for dealing with consumer-driven contracts. A lot of people are rolling their own thing. I know frameworks are not necessarily popular because they're opinionated, but well, we feel that Pact, for our use case, it actually works really well, and it's done by people who do microservices. And it works great for the workflow, so let's not reinvent the wheel when there's something that's good. But if you want to roll your own thing, it's perfectly fine. So what I'm going to be talking about contracts, I might swap the words pact and contract. So like a pact is a contract, or a pact file is a contract between 2 services. So in there, so what is Pact? Essentially, Pact is not a library, or it's not anything that you can download, not directly at least. It's a specification. It specifies what a contract should look like. I'm going to go into more detail of like the example of a Pact file, for example, but it's just saying, okay, a Pact is like a consumer, a provider, It's going to be like a set of interactions, an interaction being like it's a request, a response, status code, all that kind of stuff. And some of the philosophy that they have behind the verification is that it should suit the tolerant reader, so Postle's law, to allow for the flexibility in the API evolution. What it means is that if, let's say, the provider and the consumer agree on the contract, if the provider now starts sending more data, so like we had our user before that has like just a username, a name, and a role, if they want to say, actually, I want to put the email address in there as well, it's not going to break the interaction, because if we're doing things well, the consumer would say, well, if you send me more that I want, well, I should ignore it and let's go along. It is kind of nice because it allows for more flexibility in API evolution. It just kind of gets rid of a lot of headaches of API versioning and how do we pass from one version to the next and that kind of thing. Because it can be a bit of a nightmare. And finally, the implementation guidelines for the verification, it's saying, okay, this is, if when you have a pact, this is how you should verify that. If you do your implementation in one language, this is how you do it for, well, creating your library. And that's a nice thing that there's a lot of libraries now that are implemented for that specification. So personally, we use Java and Scala and some of the Node stuff, some of the Go stuff as well. But there's like it originated in Ruby. There's .NET, there's Swift. So it is cool because you can use that from both sides of the equation. If you have an iOS app written in Swift and it's consuming an API that's written in Ruby on Rails or something like that, you can actually have a contract between the two and they would be able to verify that and verify their interaction. That's actually really powerful. So how does that work then in practice? Now, remember there's that contract in the middle that we want to make sure the consumer is adhering to and the provider is adhering to. So the simple thing is we're going to be using the consumer and the consumer test to generate the pact by saying, well, this is the interactions that I'm doing with you. I should record them and then I'll pass them on to you so that you can verify them. So in our unit tests so we're going to start what's called a Pact mock server, which is essentially the same thing as kind of a test double or any mock server that you would start in your unit tests. And in your consumer unit test, the first thing we're going to do is we're going to define our interaction. So if you were to write a unit test for a REST API consumer, that's pretty much the same thing you would do. You would say, well, if I send this request, I should get this response because we want to mock the other side and verify that our consumer logic and our business logic is right. Same thing as we would do in standard unit test. Then we're going to trigger the interaction. Same thing. That's what you would do in a unit test to test like a REST API or REST consumer. But the nice thing is now it's going to record an interaction. It's going to say, well, you sent me this request with such and such headers, and that got triggered, and now I'm going to record it in a Pact file. Next step, the consumer is going to be sharing this with the users team, which is going to be using it in their provider test. And now they're going to be taking all that recorded interactions, all that recorded activity, and they're going to replay it against their own API, saying, okay, the consumer said that when they send this request, then we're getting back this, we're expecting this response. So now let's play the request against our service and see if we actually get the same. So it's a two-phase thing, and the nice thing is those two phases don't have to happen at the same time. The consumer will be able to generate that in their own build, play their interaction, record them, save them in a Pact file. And in their own time and on their own terms, the provider, so the users team, will be able to replay the interactions that were recorded and then verify that they're actually indeed responding with the right thing. And they can do that as many times as they want. So they have the contract, our login service never changes basically, so there's a contract that's there. And anytime they make a change, let's take the Pact, let's replay, verify, are we still happy? And keep in mind that all this is still in unit tests. We've never started anything in production. It's actually never committed even. We're still on the machine running the unit test and checking against the Pact. That's a very fast feedback that before we would have had to maybe start a few services and all that. So what's actually inside that Pact? It is deceivingly simple. There is the consumer, so our login service, the provider, our user service, and then a set of interactions that would have been recorded as part of the consumer test. What's inside an interaction? So there's an assumption that it is going to help the provider to just kind of set up its data. So it's a way to have some sort of shared data without actually having that data specified. It's common language, and you can see that being in a side of kind of BDD given when then style. Then we have our request. So simply there, what's the method of the request, what's the path, what's the headers. There's also query parameters. You can send a post and then we'll have a specific body. So all the kind of stuff that you would send in a request. And then there's the expected response, which is not much more complicated. Status code, some headers, and the body of what we expect. Or maybe we say, well, we expect no body, or we don't care about the body. Because maybe sometimes you don't really care about it. But so if you remember, so I can't go back to the whole thing, but there was that kind of dotted line between the provider and the consumer. And we say, well, we generate the pack and we share it. So how do we share it, though? Do we send them by email, or do we just say, OK, I'll just give you that pack now and just make sure you validate it? So funnily enough, sharing them by email works pretty well at the start. So if you only have a couple of services and you have one team or two teams, that works well. And that has worked well for a number of months for us. But if we start scaling up, it's kind of tricky, and we don't really have versioning, and we kind of, like, some of the packs get lost, and we lose all the benefits of doing all that system. So there's a cool thing called the Pact broker, which is going to be a central point. So that's something that's running in your environment, and that's going to be storing your contracts. That, OK, each of the teams have contracts that they want to generate. They might have contracts with different providers. And the other side is each of the teams or each of the services can go and query the broker and say, well, can you give me the contracts that are for me? So these contracts might come from different teams. So you say, OK, just give me all the contracts people have, and I'm going to verify them. So it kind of looks like just something that stores files, right? So, but there's a little bit more to it. There's a little bit of added bonus. So cool thing, dependency graphs. So you push a lot of contracts, and you start getting an image of your system saying, OK, these services have relationships with these services, and can make a nice graph. I think graph is nice. It's nice the first time you start it. You can't say that I'm really using it. But when you click on each of the arrows between the services, it just gives you all the description of the service. And what it gives us is a living documentation by example. We've tried a lot of times just doing Swagger documentation, just trying to document APIs. And as I said before, inevitably it drifts away. If you try to do it with automated generation, then you start having more annotation than code. But what we found is by having that that documentation out there, essentially each interaction is going to be readable by anybody that's going to come to the Pact broker UI and say, OK, these two services, they interact with each other. How do they do it? And they're going to do it. It's going to be by example. You're going to see, well, if I ask you for a user, that's called this. I'm doing this request, and you're getting that response. And the cool thing is we're getting that for free, because anytime we upload a new Pact to the broker, that documentation gets updated. We have a new consumer for the user service. What they're going to do, go there, see how the API is used. But the really powerful thing there is all the support that it has for the integration inside a pipeline. So whenever we push a contract, then we version it. We version the consumer. We can tag it with the environment where that Pact is actually valid for. And then there's a REST API where we can actually integrate that rather than just go and look at the pretty graphs. So how does that look now inside the pipeline? Because that's cool. We want to integrate that in our kind of continuous delivery, and we want to make sure that, well, we have these contracts and they get verified. But where, at what stage, and how do we manage the fact that we might have multiple environments and all these kind of things? So let's look at it from the point of view of the provider. And in my opinion, that's the most important part, is the user service now say, well, as part of my process now, I know I have people who have contracts with me. How do I make sure that I don't break them? So the team decides to make that change, not knowing that it might be a breaking change. And the first thing it's going to do once the change is implemented is go to the broker, saying, OK, give me all the packs that are in the broker. And let's say we have two environments, US and Europe. And it's going to say, well, give me the packs that are tagged with production Europe and production US. So that means the services that are over there, that are, say, in Europe, in the US, they have these pacts with me, so I need to make sure that whatever I'm doing, I'm not breaking them. Take all these pacts that I got from the broker, replay them, verify them. And there, right at this point, we can stop the introduction of a breaking change. And that's still on my laptop. I haven't pushed anything anywhere. I can still run that build manually before I push anything. It's so powerful to be able to do that at that stage. We didn't waste any time. Even breaking a test environment, like it's not about, oh, we don't want to break production, but even if we're saying, okay, we didn't break the acceptance test environment, that kind of stuff. Then the second part is when we want to deploy to Europe. So we're actually going to be doing the same thing. We get the packs, but maybe only for the environment, for the target that we want. And replay and verify the interactions. And then here, that's the second slightly different thing, is we can stop the deployment of something that's incompatible. The reason there's those two steps and they look very much the same is that the end of the build doesn't necessarily match the start of the deployment. You might have a bit of a gap saying, okay, we have to wait, or maybe the build was finished, somebody merged, and like a couple of days after say, oh, we need to deploy that to production. There can be a bit of a discrepancy. And similarly, we might have some different workflows for the different environments. So maybe the updated service was deployed to the States, but not to Europe. So we want to make sure that we match and we verify against the contracts of right the place that we're deploying. And everything goes well, we go ahead, deploy the service in Europe, happy days. And now at that stage, we're happy that, well, any contract that was given to us for any service that's running in that environment is actually fulfilled and we don't have any problem. The other side of the equation now is, now how do we generate these contracts and how do we actually make them available? And how can we check also that we're not going to be starting breaking against the existing provider? So, because the one thing we don't want is we don't want a consumer to actually start consuming the API wrongly and push a contract about it, because then it's going to break the provider because they're using the contract in a way that's not right. So same thing, implementing the changes. As part of the build, we're going to run our consumer unit tests. We're going to push our packs to the broker, so that consumer unit test generates our packs. As part of our CI, we're going to pushing those packs to the broker, and we're going to tag them. But we're not going to tag them as production because nothing has been pushed yet, so we're going to tag them as head. So that's the head of our consumer is, now our code, we're happy with it, we actually would like to push that into production. So now we need to kind of go and say, go back to each of the providers, say, well, I'm interacting with you and you, could you just go and check that these kind of tentative contracts, you're happy with them. I won't lie to you, this bit is not easy, because what if there's a lot of providers? Like the simple way that's told at the beginning is check out their repo, run their build. That's the very hard way. There's other ways we've been playing around with having each of the providers publishing Docker images, or that would very quickly hide all the implementation detail of the other side. That's kind of still a work in progress. But in a way, that part is probably 1% of the cases where the API is broken. It might break the process of the provider, but it's not going to break production. So there, if we find some problem, we're going to stop the deployment of a consumer that would be actually incompatible with, with Europe here. If everything is fine, then we go and deploy the service. And then finally, we go and tag it with the environment that we wanted. So now our service has agreed a contract with all their providers. It's deployed in Europe. Now it's tagged. And if we go back to the provider, now it's this new pact that's going to be verified. So caution, which is not really a caution. It's actually a really cool advantage that, well, at the beginning when we started playing around with contracts, it was very much to say, how do we test our API? How do we make sure we don't break it? And because we wanted to cover more the interactions, we didn't want to start end-to-end environments, we wanted to go fast and make sure that everything was backward compatible, all that kind of thing. So very, very technical, very, very tech-centric. But what we find now is that anytime there's two services that managed by two different teams, whenever there's interaction that's being decided, the first thing is, well, can we come together on a whiteboard and agree on a pact? Let's agree on a pact, and that's going to be something that we're going to be able to work on both sides. And that's a really cool thing, because now the microservices have put the interaction at the center of the problem, but now we're actually still putting it at the center of the discussion. Any team is going to be discussing that first before implementing anything. Also, the cool side effect is it's still consumer driven. So when there's that discussion, there's not that case of a provider. So the service that writes this API shouldn't write it because it thinks the API should look like this. It should write it because somebody is intending on using it. So then the consumer can say, well, I'm not sure why this endpoint should be this, because I'm going to need to call it 20 times to get what I want. Can you get me a different endpoint that's going to be more for what I want? It's kind of a weird way to think when we're talking about like when the developer is going to go and say, well, I'm implementing my API, I give you the documentation, go use it. Our services are going to be very small, probably only used by 1 or 2 consumers, so just write them for what they're used for. But what's the catch in all this? So that looks very cool. We deploy very fast. We check that the APIs don't break. So there was that little bit in the Pact structure, it was called the assumptions there. So given that you have a user called X, then if I send you a request for this, then you should send me the user. Well, that's called the provider setup, the state setup. So it's kind of tricky at the start. So there's a bit of setup logic, because whenever you run your Pact, you need to verify, okay, the provider needs to understand that state that the consumer expects the service to be in. It's not easy to do. So I say this is where you can stumble on some problems. It's kind of nice when the service is completely stateless, that you don't have to do this, but it's rarely the case that there might still be some data that you would expect. And if there's a large number of interactions, that ramps up the number of assumed states. So the provider can be a little bit under pressure, saying, well, I'm not agreeing to these packs because I don't have any of the states that they want, that kind of stuff. So it's one thing to be careful about. If the number of interactions are small enough, it just pushes the discussion between the two services anyway. Then, like any type of testing, if we don't have the coverage, then we won't really have any confidence. So we have to be careful that it doesn't turn into a sort of a box ticking exercise of, okay, we have 2 services that communicate between each other. Well, now we need to have a pact between them. The pact is there, we're fine, we're not going to break anything. And that means also test what's not the happy path. So let's say in the example of getting a user, what happens if I'm getting a user that doesn't exist? Do I get a 404? Do I get 500? Not. Do I get a 200 with an empty user? Do I get 200 with user doesn't exist? And these are questions that are good to be asked that it's good to ask the provider about. Because, well, they might not think about that either. But then once we have that ingrained in the Pact, then there's that knowledge that is going to be shared with everybody. So everybody's just coming, look at the documentation, say, okay, if I get a user that doesn't exist, this is what it looks like. On the other hand, be careful of being overzealous as well and causing more maintenance. So it's probably not the place to test very in-depth business logic of the provider. Like, we've had a lot of discussions recently about that in terms of validation, for example. Let's say, do you need to verify the validation logic of the provider as part of your test? So let's say when we want to create a user, and we say post /users, and we only want the username to be 100 characters max. And that's a business rule of the user service. Should the pact be, if I send you something that's 105 characters, you should send me a 400 or saying it's invalid? Or should the pact be, if I send you an invalid username, regardless of the reason, then this is the way you should respond. Then we've got to abstract that relationship between, well, some concern that's still in the user service. We don't want that concern to leak out. So something that we're going back and forth, and I think it's a tricky one to agree on. Then the automation between the pipeline. So this is where like a lot of the value is actually coming from, especially like going up in scale. So at the start, copying and pasting kind of works fine, but if we really want to ramp it up, it needs to be integrated within the pipeline. And it's not really trivial because everybody is going to have a different workflow, loads of different environments. Like there might be UAT, staging, different regions, all that kind of stuff. So you need to take the time and think about it. But I'd say if you start today with that kind of stuff, start with a copy and paste. That will already highlight 75% or 90% of the problems because it's going to cause discussions in the first place. But after that, move on to use the broker, start thinking about where and when things should be tagged, what should they be tagged with, and all that stuff. So we've been using CDCs and Pact for about 2 years now. That was one of the first things we started doing when we moved to microservices. We wanted to test our APIs. The big thing is that increased confidence. When we code, when we deploy, I would say now, it could be a stretch, but recently we don't even use end-to-end environments to actually push things because it's actually, we have the confidence that our packs actually cover most of these things. End-to-end environments can still be used for kind of high-level acceptance, synthetic monitoring, these kind of things. But we feel like we actually catch most of what would have broken the environments using the contracts. Then the second thing that was unexpected is, well, that collaborative API design. It's very powerful. Consumers are then now responsible for discussing what they want for the API, but also they're responsible for generating that contract, saying when the consumer puts an interaction in the contract, it's essentially saying, please don't break this when you change something. And if the consumer chooses not to do it, then they only have themselves to blame if somebody breaks the API. And then finally, that living API documentation. API documentation has been quite a bit of a nightmare for us from the beginning. And as the space of interaction starts filling up, well, the new consumers can go and check the existing packs, look at the usage, and we don't have to actually update the things ourselves at all. So last thing there is to do now is try it out for yourselves. If you haven't already, or if you're not even not using it yet. So some of the stuff about Pact, the documentation, the broker, that I would say definitely is stage 2 of the process. There's some more reading. So from the Pact matrix, it's an old enough article from Beth Scurry, who's maintaining the Pact broker, about that whole thing about validating head and production kind of tagging, and a few blog posts that we've written over the years on like how to use it and actually how to use the broker. Some examples of REST calls. How would you send a pact? How would you retrieve packs for a provider and all that kind of stuff.